HVAC 360 is brought to you today by the Sheet Metal Stretcher. Nothing worse than your ductwork arriving on site too short. Now there's no need to scrap it or send it back. The engineers over at the Tin Knocker Technologies have another dynamite solution to a problem that has plagued apprentices for years. This patented device gets placed over the middle of the duct. You know, the place where excess sheet metal atoms are stored. Everybody knows that. And gently warms it to a pliable temperature, which will allow the duct to be carefully stretched to the proper length. Does that seem like magic? You bet it does! This device may not be cheap, but with special financing available, it's no stretch to get yours today. Get the Sheet Metal Stretcher. Hey, what's up? Welcome back. This is episode number 104. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. How do we do that? We do that by sharing lessons learned from the field and interviewing industry experts. But we don't stop there. We encourage you to double down on your weekly dose of HVAC knowledge by jumping over to HVAC360.com and join the growing community of HVAC enthusiasts just like you. So, what's up for this week? This week, we're going to talk to Ric Turmel. He's with Tako Comfort Solutions, and he's somebody who I met over at a local AEE meeting. That's the Association of Energy Engineers. They offer good presentations, and I met Ric there, and his presentation was excellent. It is actually a little bit... I don't know how to say it. It caused a sense of urgency. I mean, this is something that you should pay great attention to because we haven't really seen these type of regulations show up too often or ever. You know, for especially with pumps. Actually, but I think the one good thing, I did get his presentation, and I will link to that in the show notes. Those show notes, you can find those again over at HVAC360.com/104. Well, that's it for this intro. Let's cut to the tape with Ric Turmel. All right, today we have Ric Turmel, who is the Area VP for the Central Region for Tako Comfort Solutions. How are you doing today, Ric?
Doing great, Matt. Appreciate you having me on today.
Not a problem. Hey, so tell me a little bit about Tako Comfort Solutions.
So Tako Comfort Solutions is a third-generation family-owned company. We're a designer and manufacturer of hydronic pumps, tanks, heat exchangers, controls, and pretty much any other accessory that you would see in a mechanical room in a commercial HVAC, a residential HVAC, an industrial, or a municipal application. We're headquartered in Cranston, Rhode Island, but we have many other facilities across North America and throughout the world, ranging from assembly facilities to foundries. We're pretty much a staple in your mechanical room in any of those applications. We are about to turn 100 years old in just a couple of years, but we are very focused on the engineering side of our HVAC systems, and high efficiency pumping is a primary thing that we focus on these days.
Fantastic. Every time I go into a mechanical room, I see a green pump. I'm like, okay, there's Tako. So
yes, we are the green pumps in your mechanical room.
So I guess today we're going to be talking a little bit about the Department of Energy, the DOE, pump regulations. So why are these pump regulations, why are they so important?
I think the DOE pump regulations accomplished two really important things. The first thing that they did is they established a commercial pump rating system for all pump manufacturers to utilize to rate their pumps on a level playing field in a certified test lab. I think the other thing that they did that's important is they forced us all to raise the bar on our pump efficiencies by setting a minimum and affecting a majority of the pumps used in commercial HVAC today. And I think that's an important piece. So we're now playing on a level playing field, manufacturer to manufacturer, very similar to what has already happened in the chiller side or packaged rooftop side. Now we're doing a very similar thing on the pump side. I think that's going to be great for the industry and great for the consumer.
So I think if people listeners out there are a little bit confused about ratings essentially they're trying to do the Energy Star for commercial equipment, basically. Like you mentioned, we have standards for the EERs for certain packaged equipment. Now they're trying to take it to pumps. So that's really what we're doing. Before you would just select a pump based on efficiency and you wouldn't really know. How you would compare the pumps before?
Yeah, previously our pump efficiencies that were being scheduled on projects was based on the efficiency of the wet end of the pump. It did not include true wire-to-water efficiency, including the energy use of the motor, and if there's a VFD drive associated with it, the total energy use of the pump itself. Similar to a mile per gallon rating in a car, now it's a complete system, a complete package, and it's rated together as a single unit. And that's different than it was in the past. So now when we talk about efficiencies and we talk about differences between pumps ratings and their efficiencies, it is a complete relative rating that truly represents the energy consumption of the pump used in an HVAC or commercial application.
So now the DOE didn't do this just on their own. Who do they partner with to get this done?
Well, they actually showed a lot of foresight, and being that this was a newer industry for them to come into, and they didn't have a lot of industry experience on the pumping side, they engaged the Hydraulic Institute. And the Hydraulic Institute is the global authority on pumps and pumping systems. They are an association of positive displacement, aerodynamic, centrifugal pump manufacturers and suppliers, and their one and only mission is to be a value-added resource and mentor to companies, engineering firms, and pump users worldwide. And so the HI, or as it's known, was consulted exclusively and to bring these regulations into the DOE. So it was a combination effort of the DOE, Hydraulic Institute, and several energy producers across the country that came together to kind of bring this regulation. And I'll say it's a very common sense regulation, which I really appreciated.
Now, common sense. I think what you're referring to is the fact that this doesn't apply to every single pump in existence. Correct?
That is correct. They took a look at the energy consumption of pumps across the entire spectrum, and they looked at what I'd call the 80-20 rule, and they attacked the 80% of the pumps that are the most consuming pumps out there and the most common pumps. So it's a very, very targeted range of pumps, really geared at the HVAC and light industrial market, and that's where the majority of the pumps are sold today.
Now, when they targeted the pumps specifically, I mean, why pumps? Why did the DOE kind of narrow their focus on pumps?
I think for two reasons. One, they've done a lot of regulation across many other areas, everything from refrigerators to washing machines and dryers. We've regulated a lot of items with Energy Star. And they started looking outside of that range. Where else are the big power consumers? So electrical motors have long been regulated, right? And there's been several levels of increased regulation on electrical motors. So now they decided to look at pumps. And pumps use a lot of energy. The pumps in commercial and industrial applications account for 40% of the total energy used in a building. So they want to look for where they can save the most energy, and this is where they target. The estimated savings, this regulation, is equal to the annual electricity required by 1.5 million homes annually. So the impact of this pump regulation will be immediate, and it's very, very impactful to the energy usage of the home.
So now, I guess, what does this mean? Getting back to the design engineers, what does this mean to them?
So, from an engineer standpoint, it'll change how they schedule pumps. The pumps will have additional information on the schedule. They will have what is known as a PEI rating, which is the tested wire-to-water efficiency of the pump. It's a match-specific rating. So when you're scheduling pumps on a project, not only will you be scheduling the wet end and saying it's going to be a Tako pump, for example, but you will also be saying it's going to be a Baldor motor, and I'm just using examples, and it's going to be a Danfoss drive as an example. It's now a tested, rated application together. And this is very important because when you're comparing a pump versus a pump, these new rating systems actually mean percentage points of efficiency. And so now when you're calculating your energy consumption on a complete project, the pump's rating has a direct impact on that, will have a direct impact on that rating for, say, like a lead project.
Now you talk about the rating. The rating itself, what is that rating, and kind of what's the range of good to bad on that rating?
So the new rating is called a PEI, and that stands for Pump Energy Index. And this metric is a ratio of the pump being rated over the representative performance of a minimally compliant pump, which is the PER, for that specific pump. And so what I mean by that is you're comparing a pump in a specific head and flow category against another pump in that head and flow category. So what the DOE and HI did is they picked pumps in certain ranges of head and flow. They tested all of them. And then they took the least efficient 25% and said, this is the new bar, and you must be below this new bar. So if your pump was in the bottom 25 or bottom quartile of efficiency, it could no longer be manufactured and sold after 2020, January 27, 2020. So they gave that new number a number of 1.0. So the Pump Energy Index means that your pump has to be a score of less than 1.0 in order to be compliant. So you can be anything below 1 and be a legal pump to sell. So as your score is lower, that is a more efficient pump. So to give you an example, a 0.50 pump would be more efficient than a 0.80 pump. And that's being compared against another pump in the same head and flow category.
Wow, that's very. That's excellent to be able to compare this. And I just like to point out. I mean, you say that the regulation comes into play on 2020. When you think about this, you're like, that's far off. That's a ways away. But realistically, I mean, the date this podcast is being published, we're coming into the last months of 2018. 2019 is just around the corner, and when you think about a design cycle that could be 18 months. This is right now. This is not, and tell me, from a manufacturer's standpoint, this has to be, 2020 isn't like, okay, we'll comply way in the future. You have to start, pushing the panic button now, right?
Absolutely. I mean, we're redesigning pumps every single day to be compliant by the time the 2020 date gets here. And one good thing about this is because there's a bar set, we have a target as manufacturers, and we're competitive. So we're going to be out there trying to be very competitive and have the most efficient pumps. But you're absolutely right. Today, they're designing projects that are going to be built in 2020. But the good news is any pump they put on a schedule today will be more efficient after January 27, 2020. So you won't have to worry about scheduling a pump that won't be compliant in 2020, as manufacturers will have to, and whatever we submit to you after that date will be more efficient than what you originally had scheduled. So there's no danger in scheduling a pump today and not getting the efficiency you're going to need in the future.
So I guess talk to me a little bit about constant load versus variable load. I know that plays into effect on a lot of the pumps. Can you talk about how those are being organized in this rating system?
Yeah, so there's three ways for a manufacturer to rate a pump, and manufacturers will rate their pumps in all three ways. if they can comply with the PEI number. So a constant load rating is either a bare pump, which means that your score must be below the 1.0, or you can rate it as a bare pump and motor. So this is a constant load pump, meaning it has no control. Again, both of those scores must be under that minimally compliant 1.0. Variable load is a rating with bare pump, motor, and what the DOE calls continuous control, which in our industry is it's under some sort of a drive control, whether it's under variable speed control or even just on a drive for setting a constant flow application. The rating is bare pump plus motor and continuous control drive. Most manufacturers will be very focused on the bare pump, motor, and continuous control ratings, simply because that gives you the highest score. It really was the intention of the DOE to make sure that tested, rated, matched pump motors and drives are what is getting out there in the field to ensure that the efficiency standards that the consumer is expecting to get are met, because that's a tested application in a certified test lab.
Now, I think that's that in and of itself. Again, we're getting to the matched set. You've tested it into a test lab. Everybody's playing by the same rules. But at least in my design experience, what I've seen out on the drawings, you have specified a pump. You don't, if it's a high efficiency motor, you're like, okay, great. You're going to have a spec section that's kind of be general. You're not really focused on that too much. You're not selecting, the brand or the type. You just want to make sure if it's, high efficiency, if it's going to be a variable speed drive that you're going to put on it. But then you have, the drive manufacturer, but you have multiple drive manufacturers as an option for this. So ultimately, at the end of the day, you're really changing things up a lot for the engineers. In a sense, you could make it simple and saying, hey, you know what? It has to be compliant with this rating, and it has to meet or exceed this rating. But ultimately, I think some of the questions that pop into my mind when you say, hey, you know what? You have specific, pump, motor, and drives. Typically drives get purchased by the electrical contractor and installed. How is that? How walk me through that. How is that going to be easier for the engineers?
Well, I think there's two things that are going on in our industry, and to some extent they've hit the air side people a little bit earlier than us. More and more HVAC products are coming with integral drives and or matched drives built into the units. And they're doing that because the rating system is, again, based on a tested packaged unit. And our industry is trying to move that same direction. We may not be as far along on the pump side as other industries, but what they did recognize is there will be applications where a different drive manufacturer or a different motor manufacturer is desired on a campus or on a large facility for consistency and serviceability. And so the DOE has given a prescriptive method for rating a pump with a motor that hasn't been tested and a drive that hasn't been specifically tested. However, you do take a small calculated deduction in your rating efficiency as a result of that. So there is potential for a non-tested combination to not meet the DOE standard. However, if you are a manufacturer who has redesigned the wet end of the pump to be compliant, it would be very, very unlikely that somebody else's motor and drive would not still meet the DOE standard. So that is a very long formula I won't bore you with today. It's in the HI and DOE standard that tells you how to calculate a pump's efficiency with somebody else's motor and drive. So there is a method for that to cover that application.
Right, so it's almost like you say, if you haven't calculated it, we're going to give you the worst case scenario that you have to add into it. Is that
correct?
Yeah.
They're going to make some assumptions on that the motor is not as efficient as the one that was tested, and that the pairing of the drive was not done as effectively as it would be in a manufactured environment.
Now, is this driving the industry to? I know that I've gone to the HR show, the HR Expo, and I've seen new pumps with the drive mounted on it. Is that going to be more common, or is it not going to really change too much? I know that. I mean, I look at that and I go, it's nice, but hey, if something happens with the drive, it's kind of integral to the pump, or if something happens to the pump, then you lose the drive. I mean, is that something that manufacturers, or maybe that the Tako is looking at? Hey, this is going to be the solution of the future, or is it still going to be we're going to have wall mounted or just mounted separately drives in the field?
I think you're going to see more and more based on the size and the application of the drive being integral to the pump. Self-sensing technology is starting to gain in popularity. It grows at Tako very significantly every year, where you don't have to have controls and sensors out in the system. And I think that's the DOE's intention is to make sure we have more match systems out there. And I think as the practical implications allow for you to build a pump motor drive combination that's all built in a single system, you're going to see more and more of that. And I think up to about 3 horsepower today, you see a significant amount of manufacturers, including Tako, that have a pump motor drive all integral and a single piece, so to speak. I think you'll see more of that technology. Now, as you get into the larger horsepowers, the physical size becomes an issue at this point in technology. So you'll see still separate motor and drive. There's electrical implications of size and spacing and height that come into play. So I think you'll always see in the larger horsepowers, there'll be a pump, a motor, and a drive, and the drive may or may not be mounted to the pump itself.
Now, just to be clear about this, you've talked about a large portion of the commercial pumps. Specifically, I guess we're talking about inline and end suction. Is that correct?
Yeah. So the way the regulation is written, are the model pumps affected are end section frame mount, end suction close coupled, inline pumps, vertical inline pumps, radially split multi-stage vertical inline pumps, and submersible turbines. Now, once you get into those categories of pumps that are affected, the ones that are included are designated as what we call clean water pumps. They are between 1 and 200 horsepower. So anything over 200 horsepower is not affected. They have to have a flow rate greater than 25 GPM and a head less than 459 feet. In typical nominal speed pumps included in that. So the pumps that aren't excluded are any non-clean water applications, nuclear, mil-spec, fire pump, sanitary type pumps, not part of this regulation. However, looking at what we produce, this is a large portion, maybe closer to 90% of what we manufacture in the industry today.
Right.
So those are the that are affected. And so from an HVAC perspective, unless it's a very, very large, tall building, your pump is going to be part of this rulemaking.
Right. I think anybody that's been out in the field or engineering for any amount of time, they look at these, they hear these numbers, and they're like, "Yep, that's pretty much if I have a pump, it's going to be that." You don't get too ridiculous out there. So I guess. How do you identify this? How is this identified? I mean, obviously, you can list it on your submittal. You can list it on the schedule. How does it actually come out into the field?
So from a field standpoint, your nameplate is going to change. So the nameplate identifying model, serial number, horsepowers, things like that will change over time. Each manufacturer, I'm sure, will plate it differently, but it must have the PEI rating indicated on the pump. It can also have the HI rating indicated on the pump. And all pumps in the categories we just discussed have to be tested. So everything has to be tested in that lab, has to be labeled in order to be compliant. So it's important. You'll see that the pumps going out into the field will now have different labeling requirements And that's why we would also suggest from an engineer standpoint, their schedules reflect some of those new labeling requirements.
Right. I think so. So, I mean, now, I mean, is that something that's available now? I mean, if an engineer was to put that on a schedule today, um, is that something that they could end up getting?
Not always. So different manufacturers of different pumps have taken a different approach as to how and when they rate their pumps and when they put it into the HI database, which can be found at pumps.org. And so you can't necessarily and won't necessarily see the labeling coming out until we get a little bit closer to 2020. But the database is starting to be populated. Some manufacturers put all of their pumps that were compliant in the database immediately. Others are only putting their redesigned pumps in the database and not loading the older model. Even if the older model was compliant, they aren't putting that in the database. So at this point, I don't think you could universally use the rating system. Now, we were trying to get out there as manufacturers and let people know what's coming, so they can be talking to their manufacturers, start looking at the new designed pumps, and picking a more efficient pump than maybe they would have in the past.
Right. Now, and just to I guess, for anybody who's designers out there, I mean, start now to take a look at this rating system, to take a look at the pumps, to start changing your specifications, or look to see, maybe if anybody who has a master spec, maybe they need to start changing that. Again, if it's something that is not necessarily in now, you can kind of forego that. During the submittal process, if they have a kickback and they say, hey, we can't get a rating on this pump, I would say, you know what, just do it anyway, but say, okay, we understand, but we're doing this for the future. But get that in your specifications now. And to anybody who's out there, doing commissioning or inspecting, or building inspectors, even engineers inspecting out in the field. I mean, obviously, this opens up a whole new list of things that you're going to need to check with your pumps, because not only are you going to make sure that the pump is labeled, come 2020, because it's going to be a requirement. Make sure the pump is labeled. Make sure that you have the right motor and the right drive, that all three are matching. Because again, even though you've probably designed it that way and you've specified it that way, it may, for some reason, not get into the field like that. There might be a last-minute switch, or something wasn't available in stock, so they gave you something else instead. So those kind of things, those are some of the quirky kind of things that I can anticipate. Just from my experience, I think that those are some of the things that are going to be happening out in the field that we need to make sure that we test for.
Absolutely. The program is going to be largely self-policed by those of us in the industry. It's going to be the manufacturers, the engineers, owners, commissioning agents, to make sure that the rules are being followed. And it's the consumer in mind here, because at the end of the day, if you paid for a pump that scores a certain rating, which has a certain amount of energy consumption expected in a year, and somebody gives you something less than, then that directly affects your bottom line, and it affects the industry, and it affects the environment at the end of the day. The goal of this was to put more efficient pumps in the field, to help with energy efficiency, and to make sure that the consumer is getting what he's paying for, or she's paying for.
Right, absolutely. Now, I guess, where can people learn more about this? I mean, we've actually, you've talked about the Hydraulic Institute. We'll get that in the show notes at pumps.org. Of all the different, URLs that we could actually kind of, we'll post this. Well, you might not have to need a reminder on how to go to pumps.org, but where can people start learning more about the changes and things like that?
Well, I think you mentioned the right website. The DOE website can be very difficult to find your way around, because there's so large and there's so much in there. But pumps.org is the repository for everything pump related, everything related to the DOE regulations. It's also where manufacturers will be registering their certified pumps, it really is the place, the one and only place you need to go for anything about this topic or anything in pumps in general.
All right. One thing that's just struck my mind, and I guess maybe you can address this a little bit. But every year you see the latest and greatest in the improvements, and some things are like constantly changing. You talk about the different technologies. When's the last time something like this has come through the pump industry? When has this been affected? When have pump designs ever changed?
Well, I think that this is kind of unprecedented in our industry, especially on the commercial side of the business. I think that this has really forced manufacturers for the first time in quite some time, at least in my time in this industry, to take a hard look at the efficiencies of our pumps, to take a hard look at what our peers' efficiencies are. And it's really driving, I think, that entrepreneurial behavior to be the best, to be the most efficient, to bring more technology to the field than was being asked for before and demanded of us before. I think this is going to be great for our industry, and I think it'll only lead to more innovation in the pumping, and given the amount of energy consumed by these items, it can have a dramatic impact on our environment.
All right, fantastic. So is there anything else as a last word that you want to add to this conversation?
No, Matt. I really appreciate you having me on today. If people have more questions, they can always reach out to their local manufacturer rep. They should have the knowledge on this. They can, of course, always reach out to their Tako rep, who also has this information. And we have information on our website. Some PowerPoint presentations that kind of go through a lot of what we talked about today that are more than willing to share with anybody to bring them up to speed. And we'll even come out to you or your firm and do some one-on-one training for your firm to explain the situation, what's going on, and how it affects you as well. So we're here to be a resource to support the field, whatever we can do as a company.
All right, fantastic. Well, thanks for being on the show.
Thanks, Matt.
All right, thanks again for Ric Turmel for taking the time to chat with us. Check out the show notes, things that I mentioned during the interview. You can find those show notes again at hvac360.com/104 for episode 104. All right, I think that this was excellent. I think that thanks so much for listening. I hope it was useful. I know that you can be one of those people that helps others out by forwarding this message onto them. Forward them the podcast, forward them the links, because everybody needs to know about this. And like I mentioned during the interview, this is 2020 is coming up for designs. It's just right around the corner, and we want to make sure that everybody's on board with this. The manufacturers are gearing up. Everybody's being prepared. So you want to be one of those prepared people, and you want to share this information with others that you want to make sure that your engineering compatriots are, they're in the know as well. Don't hide this from them. This isn't a piece to keep to yourself. So pass it along. All right, if you're not a subscriber to our growing list of HVAC heroes, go over to hvac360.com and sign up for the weekly mailing list. I give special little announcements there, so if you want to be on the inside, go over there and sign up for the list. Also, would be greatly appreciative if anybody want to leave me a ratings on Apple Podcasts. I would definitely give you a shout out in the show. So, all right, well, that's a wrap for this week on HVAC 360. Again, I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.